Problem 3 tells us that Builderman wants to play 5 games on Roblox. However, he only has time for 3. How many different combinations of games can he play? So let's write down the important numbers. There are 5 games on Roblox that Builderman is thinking about playing, but he can only play 3 of them. So let's think about which number is n and which is r so we can set up either the permutation or the combination. Well, here he's choosing out of 5 games. So n is the number of objects you have that you're choosing from, that's 5. And that means r is therefore 3 because you're selecting 3 games out of those 5. So that's our r value. So now, question of the day, permutation or combination? Well, I kind of gave the answer away in the problem by saying how many combinations, but the reason it's a combination is because it doesn't matter the order of games that he plays. If he plays Jailbreak and then Natural Disaster Survival, that's the same as playing Natural Disaster Survival and then Jailbreak in this problem. So order does not matter, therefore we use a combination. So let's set up the combination. That will be 5, c, 3, and then remember that's n factorial, which is 5 factorial, divided by n minus r factorial. Well, 5 minus 3 is just 2, so that's 2 factorial. And then times r factorial, which is just 3 factorial. So let's solve this. I'm going to move down here. We have 5 factorial. I can write that as 5 times 4 times 3 times 2 times 1 is just 3 factorial. And then what that allows me to do is cancel out the 3 factorial in the denominator here. So what I'm left with is 5 times 4 divided by 2 factorial, which is just 2 times 1. Or that's just 2 only, because 2 times 1 is just 2. So let's just do the math, because this one is simple to do. 5 times 4 is 20. 20 divided by 2 is just 10. So all this means is that if Builderman can play 3 games only out of 5 he wants to choose from, there's 10 possible combinations for him to play.